Bring on the internet. By the time we're done here, we will configure the most common form of NAT, and that is NAT Overload. It's so common, in fact, that I've never, in 20-some years of network administration and engineering, ever had a business that did not use this feature. It's like, it should be like step number 1 on your resume. I can configure NAT Overload. And why wouldn't it be? It's the feature that allows all the private IP addresses in your network, the things that powers your entire internal organization, to access the internet just using a very few, sometimes even a single public IP address. So what we're going to do in here is we're going to go back to Arizona, and we're going to configure the internet connection there for NAT Overload. And just to reorient ourselves, Arizona is not a standalone site. There are actually other sites that are connected over here. We've got Nevada, we've got Florida, and you notice these guys do not have their own internet connection. I know it's a cloud, but that's a Metro E-Cloud. That's a private WAN. They come across a private WAN connection to Arizona. I couldn't fit it in here, but this is where the internet connection is coming off. So what we're going to do is configure Arizona in this video to... Going back, configure Arizona to take all of the addresses in Arizona, the addresses in Florida, the addresses in Nevada, and translate them out to the internet. Now, a quick review of the physical gear that we've got. We've got these sites, Nevada and Florida over here, that are doing their thing, right? Over here is the main site, Arizona, and I want to zoom in a little bit so that you're able to see what the connections look like. First off, we've got this blue cable, which, let me scoot over here a little bit. This blue cable actually tracks around to this guy, which is emulating our Metro E. Metro E often acts just like a big switch in the cloud. You can do your VLAN, you can do all kinds of stuff. So we've got Metro E, that's what allows Nevada, Arizona, and Florida to link together. This red cable right here goes to the switch below it, and this feeds in a live internet connection, a very real internet connection. This guy right here is my computer, the one that I'm talking to you on right over there. And this computer right here is going to get its internet access through the Arizona internet connection once it's all set up. And we'll be able to verify using some show commands that the translations are really taking effect. Sound cool? So let's dive into our terminal. There we go. Forgot to open it. So we've got Arizona RTO1. That's, again, going back to the scene here, this router. You can see my console cable is actually plugged right in there. There is the internet connection right there, 203.0.113.2, assigned via DHCP. Now, it depends. A lot of times businesses will use static IP addressing that the carrier will give them, or DHCP. Usually the smaller business will use DHCP. NAT will work with either one, no problem at all. I also have all of my VLAN interfaces, which is providing the routing for the internal devices. To configure NAT Overload, it's 3 steps. The first step is kind of a doozy because it's a whole nother skill. It is configure an access control list. Now, I know when a lot of people hear that, they're like, okay, access control list, that must be like firewall rules or something. No. Access control lists are used for so much more. They're used primarily to identify traffic. It just happens to be that you can use them as firewall rules, and you can use them to block certain types of network traffic coming in and out of the network. And in this case, we're going to use access control lists to identify the traffic that is permitted or denied to go through the NAT process. Now, for the sake of this video, I'm going to assume that you've seen access control lists in another skill, because, I mean, there's literally hours of lecture that you can go through on that one topic. But I'm going to keep it really simple in this because our access control list can be an extended one, which says, I'm going to NAT when I'm going from this source, accessing this one destination, and so on and so forth. Or we can go very simple, which a lot of people do, and just do a standard access control list. This identifies traffic only by the IP source address. So I'll say these guys, these subnets are the ones that are allowed. The Florida, the Nevada, these sites, those subnets are allowed to be NATed. That's step 1, create that access control list. Step 2 is probably the most fun and the easiest of all. It is to identify interfaces. We need to tell our routers which interfaces are inside and outside of the network. And just looking at this picture, And it goes, okay, that's an outside one. That's an inside one. I mean, you and I can look at it. Oh, yeah, that's public, but the router doesn't know. So we have to go tell it. The third one is a doozy. This is the one where we come in and assemble the whole thing and start the NAT process going. I'm gonna call this the NAT global command. It is only one command to turn on NAT overload, but it's long because it takes all the pieces. It says, okay, we've got an access list. These are the source's address. We're going to translate them to here, this interface or this pool of addresses, and then we're going to overload. We engage the overload feature. All of that on one nice long line of configuration. So let's do it. So we're going to go into our HQ router. Got this right here. First step, create the standard access list. I'm going to go to global configuration mode. As you may or may not know, depending on how much access list experience you have, access lists can be numbered or they can be named. Well, long ago, I vowed to myself never to use the numbers again because it is so much better. I'm just going to go to the beginning of this line, type in IP access list. That's how you create a named one. It's so much better to be able to go in and say, I'm going to name this thing, because when I go back later and do show commands, I go, oh, that's what that access list is, versus, oh yeah, access list 53, what was that? So I'm going to use a nice logical name here. I'm going to say NAT sources, right? Now, it is case sensitive. I always type all capitals just so I remember that it's always capitals. It's consistent. And now I permit the addresses that I plan to NAT out to the internet. So hang on. Let's look back at our diagram. We've got Arizona. Let's look at the bigger picture. We've got the Arizona site right here with all of these VLANs. Now, if you were with me in the VLAN skill, you know that we went into Nevada and we deployed VLAN 10, 20, 30, 40. We went into Florida. Actually, I did Florida behind the scenes and set up all the VLANs here as well to kind of mirror this, because each one of these is set up as a template, a site subnet. So rather than create an access list that matches every single one of the subnets, what if we said, I'm going to create an access list that matches every one of the site prefixes? Now, before I show you how we're going to do that, you could also go really lazy, which some people do, and that's okay. It works, and you can match the entire 10 network. I could create an access list. For example, I could say ACL. I want to match everything starting with the number 10, and then use a wildcard mask. If you haven't, again, done too much with access lists, wildcard mask is the opposite of a subnet mask. It identifies what is significant. So it says anything starting with 10 is valid to be NATed. I don't like doing that because later on when you get into more of the complexities, it's like, I need to back that off a little bit and let's rework that whole thing. So you can go that way, but I'm going to go at least a little bit more specific. So the way that we would create wildcard masks for this or accessless match statements is to figure out what the opposite of that bit notation, the CIDR notation is, because we need that for the wildcard mask. So a /21 is 21 So there's our class B, right? There's our 16 ones, 17, 18, 19, 20, 21, 22, 23, 24, and the rest are zeros, right? So our subnet mask for a /21 is actually 255.255. What would that be? That'd be 248.0, right? And the best way to figure out a wildcard mask, which is what we're going to need for our subnet mask, is to subtract that from all 255s. That's kind of the shortcut way. That'll give you the inverse mask, which is what access lists use, 0.0.7.255. Now again, if right now you're like, what are you doing? Go over to access list. There's a whole skill on that on CVT Nuggets, and watch that, because it could be totally confusing if not. So that's going to be our wildcard mask for each one of these sites. So we've got 10.16.0, .8, and .16, right? With this wildcard mask attached to each one of them, that will identify each one of those sites individually. So let me get my stuff hidden here and go back to our prompt, named access list. I will say permit, question mark, what are you matching? 10.16.0.0. What is that wildcard mask? 0.0.7.255. Enter. Good. Hit the up arrow. That's the entire Arizona site. There's our entire is that Nevada? Yep. Nevada site, and then Florida right there. 3 statements, 3 sites, all being identified as permitted to do NAT. Now, just a flyby side note here, if I were to deny a host or a group or something like that, you can actually put deny statements in there. Remember, it's not like a firewall here. It's denying them from being NATed, not from being routed. So as the device comes through, if it matches that, it's like, oh, you're denied. If I put a deny statement in there, I just won't NAT you, and you'll pass right through unnatted, right? So that's how you would use those deny statements. So I'm going to come back. Let's just verify all looks good. I'll do a show IP access list and hit the enter key. Yeah. So right there we've got sequence 10, 20, 30, each one of those sites being identified. I love the sequence numbers because I can squeeze in deny statements if I have exceptions that I want to do later. That's in more of the advanced NAT side of things. Good. So our step 1 is done. Step 2, super easy. Identify our interfaces. So go into each interface. I'm going to say gigabit 0/0 IPNAT outside. Okay, identify. Now you notice it's hanging a moment there because it's actually engaging NAT processes behind the scene. Now the other, it's kind of like you turned on a light switch and NAT is now working. I'll go into interface VLAN 10 now. IPNAT inside. You got to do this for every one of them. 20 inside. 30 inside. Now, you can use interface range commands if you don't want to do them one by one like this, but, I mean, you're configuring NAT. It's kind of a big deal. I like doing that. That's step 2. Cool? Not too bad so far, right? So, we've identified the source addresses using an access list. We've identified the interfaces. Now, it's time to put them all together. Here's your big global NAT command, and then we'll test and see how everything's working. Go to global configuration mode. Command is IPNAT. So let me be a translator as I'm going to kind of convert it to human speak as we go. So IPNAT is saying I want a NAT because we're in the global mode. I want a NAT, and now it's going to. I mean, you're like, oh, yeah, that's right. From the inside of my network. Now this is where, if you remember the different address types. Inside local, inside global, outside global, all those different address types that I talked about earlier in the skill. This is where you start seeing that language being used. You can define NAT from the outside in or from the inside in. You could do all kinds of crazy stuff with that, but most of the time we're going to say, I want to do NAT and I want to configure it from the perspective, that's kind of what this is saying, from the inside of my network out. Now watch this. So I'm saying IPNAT inside. Now it's saying, okay, well, define the inside. What do you mean the inside? I'm going to say, well, the source addresses on the inside of my network, they're actually in the access list because you can see right here, we can do others. And by the way, I'm going to show you how to do static NAT later on, all that kind of stuff. But I'm saying, I want a NAT. I want a NAT from the inside of my network. And by the way, that's defined as the access list. And I don't remember what we named it. NAT sources. Right click, copy, paste, NAT sources. So router, this is what defines the inside of my network, right? Okay. It's like, okay, got it. Okay, question mark. What do you want to send it to? Ooh, big deal here, right? Do you want to send it out the interface and use a specific interface for a global address? Or do you actually have a pool of global addresses? Big difference, kind of. The interface has an IP address assigned, right? We saw when we went on this router via DHCP, it got an IP address from the service provider. If we choose interface, what it's saying is, I'm going to NAT those source addresses that you specified right there, the NAT sources, right? I'm going to take those and I'm going to translate them out the interface. Which interface? This guy right here, the red interface, gigabit 0/0. And I'm going to use whatever IP address is on that interface as the NAT address. I love that because I know a lot of people have DHCP assigned addresses. If you have a DHCP assigned address from the carrier, meaning from the ISP on your router, you never know what it's going to be, and it could change at any time. So that means if you're going to use a pool of addresses where you actually type in what addresses are there, and that changes, that means your whole NAT configuration changes. The interface command, the reason I dwell on this a long time, because the reason it's so great is because that address can change all day long and the router adapts to it. It's like, oh, well, we were using 2.0 whatever, but now we're using 1.5, whatever. I'm going to use that for my NAT addresses now, right? So I'm going to show you that first, and then I'll come back and show you if you had to do a pool, what that would look like, because it's one more step. Okay, so we're going to say NAT sources are the source, and they're going to go out the destination interface. This is where we tell it what interface we've got. And again, I'm looking here, gigabit Ethernet 0/0. GI 0/0. Oh, and don't forget this. I'll hit the question mark right after here. And there it is. Overload. What do you think happens if you forget to put that overload at the end of it? Do you think NAT will work? Think about it. Pause if you need to. I said, go from this group of address, this source, out the interfaces, do NAT, but I forgot to put overload on there. It will work. For one, the very first computer that gets there to try to access the internet gets internet access, and then it's used up the outside interface. It won't overload it, so it's like, okay, I'm done. No more. Probably increase your employee productivity. It's like everybody gets into the office early so that they can be the one, because remember, it caches that NAT translation. And so as long as they keep accessing the internet, they'll keep being the one. So there's employee of the month. Get to the office early. Get internet access. So we're going to say overload, which does the port address translation. Enter. Okay, hang on. That's the command, by the way. Let's just do a show run, and I'm going to include IPNAT, because I just want to put that together, because you're going to, if you're doing this in the real world, if you're studying for an exam, you're going to need to generate a line like this by yourself, of course, using context-sensitive help. Plain English, IPNAT says, I want an NAT. The router's like, okay, what do you want to NAT? I'm going to say I'm going to NAT from the inside of the network out. And by the way, the inside of the network is identified with the addresses in the access list NAT sources. That's what the inside of the network means, router. So look at that to figure out what the inside is. Okay, great. What do you want to NAT them to? Oh, I want them to go out this interface and use the IP address on that interface as the NAT address, and I want to overload it. So I want to share that IP address among as many clients as I possibly can. That's the configuration. Now the question is, does it work? Let's find out. First thing I'm going to do is I'm going to check my network properties on the computer. I can see the Dell DocNIC is the only one enabled. I disconnected from Wi-Fi. I'm going to open up my command prompt, do an IP config, and right now I've got 10.16.5.50, which tells me I'm part of that VLAN 30 in Arizona. I'm gonna ping 10.16.4.1, which is my gateway. So it looks like all is well. We've got my computer connected right here. It's able to ping the gateway on the VLAN interface. Now, what's left is let's go in and surf the net. So I'm gonna open up Firefox and loading. Bring it over into the picture. We're having trouble finding that. Oh, I think I know what that is. Hang on. I'm going to do a ipconfig /all, because I think I statically assigned this back when, and I never set up any DNS servers. So let's go back here. Floop, right there. Dell DocNIC, bring that up. IPv4, yeah. That'll make you feel the internet being down. So I'm just going to use Google. That's 8.8.8.8 as my primary. And level 3, I think, is 4.2.2.2. Two very easy public DNS servers to remember. Now, let's come back here to Firefox and refresh. Woohoo! We've got internet. Let's go to, let's do something cool. Speedtest.net. Let's see how we're going. Now, I'm going through, these are old switches. This is 100 megabit per second speed. I've got a 300 megabit per second internet connection. So I'm going to hit go, and let's see what happens. Give me something. There we go. Looks like I'm getting we're kind of capping out at about 80 megabits per second, which on a 100 megabit per second link is about what I would expect. We are good. Okay, good. So we know that the internet connection is working. Let's go back to the terminal. Hang on, where are we? There we go. Hit the enter key, and let's verify that NAT is actually working. I'll go to, by the way, this is the big command that you want to type. Show IP NAT translations. Hit the enter key. Yeah, right there. I can see my, okay. Oh, there's such good. So notice all the terms, inside global, inside local. If you need to review those, you might want to do that. Go back and look at what are those terms and what those mean. I'll explain some of them right here. Notice what's happening here. I can see that this guy, so if I hit the space bar, I can see it's like, look at all, what? There's one computer accessing Google as one and speedtest.net as another. Look at the number of connections that we open. What? And it's a wonder why we run out of port numbers on a single IP address, right? That's what I'm saying is, one computer in a network can easily chomp up 100 port numbers just with a few connections, right? So you can see here's the DNS lookups that I've been doing going out. That all does NAT. So what do we see here? What can we learn from this? Well, first off, inside local. Remember what that means? It is I own it and it's private. It's inside of my network. These are the private addresses. These are all the source addresses and port numbers. Remember, this makes a socket. Source address and port number that's originally going out. Okay, what are they going out to? My inside global. I own it. It's under my control. And it's public, right? That's the meaning of those two. It's going out here and it's saying, okay, it's becoming, so this one went out and became the public address 203.0.113.2 on the same port number. Notice it's using that PAT, port address translation. Same thing here. It's doing that translation. The outside local and outside global is the same. And roughly speaking, it's under somebody else's control and it's public, right? Notice right there, these are all the servers that I ended up accessing out on the internet when I just went to those two sites. And by the way, I mean, I've got other stuff on my computer running. I'm sure I've got like background tasks, stock checker, whatever else is running behind the scenes on my computer. So those are going out as well. It's going to the destination port. Notice HTTP, HTTPS, these are SSL, right? So all these connections are going out either on HTTP or HTTPS. As I scroll down, notice these. Now I've changed to the UDP protocol. This is the one UDP port number I said to remember on port 53. That's DNS lookups. All these are DNS lookups that are happening, right? Pretty spectacular. Okay, now outside global, it's somebody else's and it's public. So this is the outside addresses. Now outside local, this is essentially how do I see that outside address? Most of the time, unless you're doing something crazy, these two for your normal NAT overload will be the same because we're not making the outside appear as a private address. It's just appearing like it normally does. So it's working. We've got NAT overload going. Hang on. I know. You're like, we've arrived. There's one more thing I want to show you. What if your ISP gives you a pool of addresses, right? We just used the interface address, which if you look right here, 203.0.113.2, if I do a show IP interface brief, hit the enter key, that's, notice, bing, bing, right? We got that? But what if the carrier gave us a pool of addresses? Hang on, let me get back here. Instead of just for example, notice I've got 203.0.113.0/29. That means I actually have, if I were to reverse engineer it, 203.0.119.0 through 7 before the next 7. So .3, .4, those might all be assigned to me. Maybe they gave me some for static addresses, static NAT hosting, which we'll talk about later for servers that are run inside. And maybe they've given me a couple more that I can use for my extended, if I run out of port numbers like we just saw, I might need to extend that range. So here's how you do it. Go into global config mode. It's going to add one more step to our 3-step process. IPNAT, and I'll hit the question mark, and notice one of the options is pool. I'm going to define a pool of addresses. Hit the question mark. It says, what's the pool name? And I'll say, this is my public IPs, right? Okay. What is the start address? Okay, that's where I'm going to say 203.0.113. Maybe 2 is the first one I want to use. And I'm going to go through 203.0.113. Let's just say 4. I want to use those first 3 addresses, 2, 3, and 4. Oh, hang on. Question mark. Oh, what's the prefix length or the net mask? I'm going to say prefix length. I can use a /29. That's, by the way, just make sure you guys are following. This /29 right there is the prefix, right? So I can do /29, or if I want to type in the decimal version, the dotted decimal network mask, I can do that as well. Hit the enter key. I've now defined the pool. So instead, and at that point, I just do a kind of swap and replace. Watch this. I'll do a show run. I'll say include IPNAT. And there's my NAT command right there. So I'm going to go in there. I'm going to highlight that guy. And I'm going to say no. Bam. I just blew up NAT, right? It says, oh, hey, are you sure you're going to take down the internet? Are you sure you want to delete everything? Yeah, yep, it's gone. And then I'm going to hit the up arrow. I'll go back and remove that no. Control E, go to the end. And instead of, so hang on, let me go back here. I'm modifying the command to say, I want a NAT. From the inside source list defined as NAT sources, and I want to go to the destination. Instead of going to the interface, you see the connection? I want to go to a pool. And the pool that I want to go to is public IPs, right? The pool that I defined up here with a range of addresses. And I'll hit the question mark. And again, if I don't type overload, how many NAT translations will I get? 3. The first 3 addresses to go through will end up getting translated, and then it'll stop. No one else can access it. But when I type in overload, that's where it's going to use PAT, the port address translation, to make sure that all those addresses get used up. So when one of them gets maxed out on port numbers, it shifts to the next. That maxes out, shifts to the next, and starts recycling the ones. They time out as people close connections and so on. The NAT translations time out, and it just gives me, I mean, if you think about that, that's what? Close to 150 some thousand port numbers more that we would be able to use for our NAT translation. So I'll hit enter, same deal. Now, let me just do a show run, include IPNAT. Now we're doing, instead of translating to a specific interface, we're translating to a pool of addresses, 3 addresses that we can use. Whoo, that's fun. I love doing that. I've got my little, he's my little 5-year-old sitting on the couch, and I went woo, and he's like, hey, and so he's cheering too. So anyway, we now have the internet translated, accessed from all of the different sites in our network. NAT Overload is working. You now know the most common form of NAT. You know the most common configuration in the world. I would say dwarfed only by basic IP addressing that you apply to all of your routers. I hope this has been informative for you, and I'd like to thank you for viewing.